Okay, it's been a long time since I made a video, and so we're going to continue with the Vickie project, and I'm going to start a quick video this morning concerning the displacer crosshead guide. This thing's kind of eluded me for a while. At least my mind's eye hasn't been able to completely picture a 3D image of it. So what I'm going to do is, I do have it pretty well figured out by this time, but what I'm going to do is I'm going to go by the instructions that Hal has provided, and I'm just going to go step by step and do what he says, and hopefully in the end it's going to come out looking like the picture. I've got it set up on the mill. And what I'm going to do is I'll show you the setup, and then we'll go to the computer and I'll show you what it looks like in in a two-dimensional drawing. So let me zoom in on the setup here on the mill, and I'll explain that, and then we'll go from there. Okay, you can see there it's a fairly simple setup. I've got a piece of 3/4 inch brass dowel. It is exactly 3/4 of an inch, I hope. And we've got it chucked up in a 4-jaw chuck. And that 4-jaw chuck is mounted to a rotary table that's mounted vertically. And let's see, I've started milling a slot in here. This slot needs to be approximately 2 1/8 inches long, end to end, and it's milled with a 1/4 inch end mill. And it's got to go down 500 and some thousandths, I think 532 thousandths, and then it has to get widened out. So that's the first step. And supporting the end of this thing, I've got a shop-made tailstock, I guess you'd call it. And I put a little jack underneath here to make sure that this is stable. Although I think it would be. There's very little pressure on it right now. The 4-jaw chuck would probably hold the whole thing, but I've added some extra assurances here to make sure that I don't have any problems. And I've set the rotary table up to 0. Now this rotary table, this setup is going to be used throughout the milling process, and there's a whole lot of steps here to get this milled to the right configuration. And what I'm going to do is I'll go over to the computer and move the camera over there, and we'll take a look at exactly what this thing is supposed to look like. I've started the slot, which is the first step, and I'm down 300 thousandths with just the 1/4 inch slot. Once I get the full depth, which is not the full diameter of this bar, I'm going to have to widen this slot out to the point where each side is 179 thousandths, if I recall the dimension. So we'll look at that on the computer and look at the first few steps. And this is going to be, I think, part 8 of the Vickie project. And I'm thinking that there's going to be a bunch of segments to part 8. Probably I'll make them part 8 A, B, C, D, because I'm not going to be able to show this in one operation. So we're going to have to do a bunch of changes to the rotary table, and maybe reset up the jack here and a few things like that. So with that, let's go to the computer, and then we'll come back and we'll do some more milling on the milling machine here. Okay, I got Vickie on the screen, my AutoCAD program. Usually I draw everything out, even if drawings are provided. it helps me work out any bugs or problems, and it helps me understand what things actually look like. So anyway, with that, I'm going to give you a quick overview of the Crosshead guide. So let's see here. Let's zoom in here on the. I kind of got an overall drawing here. And this little part right here is the Crosshead guide. Okay, and this is a bottom view of it here. So this Crosshead guide attaches to this this piece here, and also this longer piece here, which we've already machined. Let's see here. Somewhere here, I have some additional drawings of it. Here they are, right here. So this is the Crosshead guide, basically. This is what we're going to machine. And if you look at the top view, I guess, or side view, I guess, is what it would be, I suppose. This would be the top view. We got this slot that's milled all the way through it. And it's a little hard to picture this in your mind's eye, believe me. I know it's a simple little part, but it's kind of boggles my mind. Anyway, I put the instructions right here in AutoCAD. So we're going to start off with this portion down here, where we're going to mill a slot in the center of that 3/4 inch bar that we just looked at. And the slot, we're going to mill it with a 1/4 inch end mill. And we're going to make multiple passes, and we're going to go down 560 thousandths. Now remember, the bar is 3/4 of an inch, which is 750 thousandths. So we're not going all the way through. And then we're going to widen the slot out. Let's see. We're going to widen it out till the walls are 179 thousandths of an inch thick. Okay, and let's see, the slot is going to end up to be 392 thousandths wide, is what it's going to end up to be. And then after we finish that, we're going to widen a portion of the slot to the widest, to 530 thousandths, and we're going to, for a short distance. So right now, where the slot is, we're going along the bar 208 inches right now. So with that, we're going to go back to the mill, and we're going to get busy, and we'll look at this drawing again several times in the process here. And this will be part 8A, I guess. And so this will be the first little segment for the Crosshead guide. So with that. We'll go back into the shop and look at what we've got on the mill. Okay, I'll call off. Okay, we're down 300 thousandths now, as I said before, and so I'm only going down 20 thousandths per pass. I'm kind of cleaning the slot out a little bit as we go because it just keeps filling up with chips. Remember, we're going down 530,000. I might also mention that I'm carefully watching the DRO to make sure that I'm just traveling 2 1/8 inches down the slot. I don't know if that's got to be exactly that, but I'm just following the plan. So we're down 439 thousandths now. I double checked in my instructions here. So the depth is 560,000. I know I said something different here before, but I double checking is 560,000. Looks like we got 2 more passes to go here. Now I mentioned the Z-axis dial on the mill isn't exactly right, so I have to watch the DRO. Okay, there we are. We're down 560, so this will be the last pass. Okay. Okay, we're down 560,000. We got a nice clean slot here. Well, now we got to widen that slot. The slot theoretically is 250 thousandths wide. I did use a brand new end mill that hasn't been sharpened before, so it should be pretty close to 250 thousandths. So we got to go out to 392. So let me shut the camera off for a second and do some calculations. I'll be right back. Okay, I'm back. I took the 392 thousandths width and deducted the 250. Divided by 2, that gives me 71 thousandths each side of center. I'm not sure how much I can take off here, but I'm going to go over, let's see here. Change the Z. I've lost the Z axis at there, and I've zeroed it. So we're down 560. I guess I shouldn't have zeroed it, huh? Okay, so let's see here. I'm going to go 71 thousandths. So let's see. The y-axis has been locked all this time, so unlock it. So let's go 10,000. That looks like that's working out okay. Go back to 0 here. Now let's go another 10. There's 20,000. Back to 0 again. Okay, we'll take another 10. By the way, we're making a conventional cut. another 10. This brings us to 40. Remember, we got to go to 71. There's 60. Okay, I'm going to check the width of the slot at this point. See where we're at. I don't know if I can get in there with a caliper or not. So we're at 310. I don't know. I can't probably put that in the camera. Well, we're at 310 approximately, the best I can get the caliper in there. So with that said, so 310, we went out 60, so 60 and 250 is 310. So we're right on, actually we're right on the money. So I guess we can continue on. I'm going to just go 70 instead of 70. Let's see, it says 79. It says, or I figured 71, right? I think I figured 71. What was it? It was 392 minus 250 divided by 2, 71. So considering we're pretty darn close, I'm going to go out another 10. Down here to 1.875. That's where we've been going here. Okay. Then I'm going to go over to the other side of 0. There's 0. I'm going to go 10,000. Well, there's the first 10,000. So we're starting at the opposite end now, so we're conventional, it's a conventional milling cut, same as before. go at this a little differently. Let's get a... I'm going to shut the camera off while I work this out. Okay, I milled out another just about 1/1000th on either side. So let's see here. I use this this type of bore gauge, whoops, to actually measure it, and I'm exactly. I put that in there and set it, and so I put the calipers across it. Now it varies a little bit. We're at 393 right now, so it's pretty close, pretty close. But we're going to call that it. We're going to call that the end of this little segment. And that gives you a little bit better view of the slot for a few minutes there. And the next step is to widen the slot out. So right now it's 392. So we need to widen it to 530 thousandths at one end, just for a distance of a ½ an inch or 470 thousandths. So that'll be the next step, and that'll be, so this will be segment A, and we'll get this up on YouTube, and then we'll proceed to the next segment, because these are going to get too long and there's too many steps. So hopefully this will guide somebody through making this thing, because it is a little hard to get it pictured in your mind's eye. So with that, we'll zoom out a little bit here, and we'll call it quits for now.